This webinar is brought to you by the team of Navcara Consulting. I'm Shanmukhi Priya and I'm very passionate about blockchain technology. Now, I have co-authored 3 papers that focus on different use cases of blockchain, and I'm also a joint inventor of a blockchain patent. A recorded version of this webinar will be available on Navcara's YouTube channel. We'd love to hear from you, and so if you have any questions, please write them in the chat window and I'll get back to you at the end of the webinar. No part of these materials should be reproduced or published in any form by any means, electronic or mechanical, including photocopy or any information storage or retrieval system. Navcara is a leading global consulting company that is specialized in digital transformation. We serve clients across a spectrum of industries, including healthcare, public, federal, and commercial sectors. Here's the agenda for today. We'll be talking about the history of blockchain, the introduction to blockchain, and a few of its characteristics. We'll also talk about the different types of blockchain, its versions, and then we'll move on to a very interesting concept in blockchain, the smart contracts, and then we'll conclude with a short Q&A session. The history of blockchain. Blockchain technology was first described in the year 1991 by research scientists W. Scott Stornetta and Stuart Haber, with the objective of coming up with a computationally practical solution for timestamping digital documents such that they could not be tampered with or backdated. They developed a system using the concept of cryptographically secured chain of blocks to store the timestamp documents. The concept of Merkle trees was incorporated into the system in the year 1992, making the blockchain more efficient by allowing several documents to be collected into one block. It stores a series of data records, and each data record is connected to the one before it. For instance, we have transaction A and transaction B. Now, each of this transaction would be hashed individually, resulting in hash A and hash B. Now, hash A and hash B would be combined, resulting in hash AB. Similarly, we have transaction C and transaction D. This would also be hashed individually, resulting in hash C and hash D. Now, these two would be combined to result in hash CD. Now, the combination of hash AB and hash CD would result in the root hash or the Merkle root. In this way, the latest record in this chain contains the history of the entire chain. However, this technology went unused and the patent lapsed in 2004. A system named Reusable Proof of Work or RPOW was introduced by Hal Finney in 2004. This was a prototype for digital cash and is considered as one of the early steps in the history of cryptocurrencies. They solved the problem of double spending by keeping the ownership of tokens registered on a trusted server. The server was designed to allow users throughout the world to verify its correctness and integrity in real time. The theory of distributed blockchain was conceptualized in the year 2008 by Satoshi Nakamoto. He improved the design such that new blocks could be added to the initial chain without requiring them to be signed by trusted parties. It utilizes a peer-to-peer network for timestamping and verifying each exchange. This can be managed autonomously without the requirement of a central authority. Now, all of these improvements help blockchain become the backbone of cryptocurrency. Since then, the evolution of blockchain has been steady and promising. Blockchain gained a lot of momentum by 2016, and the file size of cryptocurrency blockchain has grown from 20 GB to 100 GB since then. So, what is blockchain? In layman terms, one could think of it as a literal chain of blocks, but in my opinion, it can be best described as a shared, distributed, and decentralized ledger combined with a consensus algorithm to generate certain characteristics, thereby adding a layer of trust. Now, before we move on to the characteristics, I would like to discuss the block contents. From a developer's point of view, each block contains a lot of parameters, but these can be classified into 3 main parameters, namely the data, the hash, and the hash of the previous block. Now, the data depends on the type of information that is to be stored in the blockchain. For example, if we look at a Bitcoin blockchain, it is very obvious that the information saved in this blockchain would be related to the Bitcoin transactions. Hash. This is calculated cryptographically and is used to uniquely identify a block in the network. Hash of the previous block. This parameter contains the hash of the previous block. To understand this better, I want you to assume three, three blocks in a chain. Say block A, block B, and block C. Now the block C would be containing its own data, its own hash, and in the parameter of previous hash, it would be saving the hash of block B. Now block B would have its own data and its own hash. And coming to the previous hash, it would save the hash of block A. But coming to block A, the parameter of previous hash would be null because this is the first block in the chain and it has no previous block linked to it to save its hash. Such blocks are generally termed as genesis blocks. So how does the blockchain technology work? Now, blockchain technology requires a network, and every network consists of multiple nodes. By nodes, I'm referring to a laptop, PC, mobile, or any electronic device that can be used to gain access to the network. Blockchain uses cryptographic principles to encrypt the transaction details before the transaction's information is displayed to the remaining participants of the network for verification purposes. Once a majority of the network accepts that the transaction is legit, only then this transaction will be added onto the blockchain. Let's look at an illustration to understand the cycle of encryption and decryption. Say we have a piece of plain text. Now, with the help of a public key, we can use the process of encryption that would result in a ciphertext. Then, with the help of the private key, we could use the process of decryption that would result in the plain text. Let's look at an example to elaborate this further. Say we have person A and person B. Now let small a and small b be the logged private keys of person A and person B respectively, and capital A and capital B be the published public keys of person A and person B. So when person A wants to send a piece of information to person B, person A would have to use his own locked private key and person B's published public key. With the help of this, the person A can use encryption and get the ciphertext. Now, once this ciphertext is received by person B, he would have to decipher it. So, for the sake of deciphering this ciphertext, person B would have to use his own private key and person A's public key. Now, in this way, person B would be able to view the same plain text or the plain information that person A intended to send to person B. Now let's look at a few characteristics of blockchain. So the first and foremost characteristic of blockchain is that it's decentralized. But before we understand decentralized, let's talk about a centralized authority. In the scenario of a centralized authority, there's a single point of authority, or you could also think of it like a single point of failure. Whereas in the case of decentralization, every participant has equal control, as in there is no single point of authority. So, for example, let us assume that all of us are part of a blockchain network and all of us are participants in this blockchain network. So, if I or anybody in this network can have the equal authority to allow or to reject the occurrence of any action or any event. Then we have distributed nature. Now, when I say that a network is distributed, it means that each and every node or each and every participant in this network has equal access to the ledger that is shared within the network. For example, assuming that we are still in the same network, if I can see or if I know that person A has sent $50 to person B, then all of you know that person A has sent $50 to person B. And if such a transaction has not occurred or it is not there on the ledger, then none of us can see it. So I want to convey here that whatever one participant can see in this distributed network, every participant has access to the same ledger. Then we have transparency. Now I would like to explain the procedure, the characteristic of transparency with the help of the example that depicts the central authority of the banking system. So, in the current processes, if a person wants to send money to another person, they cannot send it directly, be it via any platform like GPay, etc., or via net banking. What person A has to do is send the money, and once this person sends the money, it basically reaches the bank, and the bank would then send it to person B. Now, this bank is not a single entity, it is more like an organization of multiple entities. So, you wouldn't be able to trail your money exactly. So, in this scenario, there's a lack of transparency because the moment you're transferring the money out, you are not able to trace the exact flow of the money. Whereas, if we introduce blockchain here, I know whom I'm sending the money to. As in, if person A wants to send money to person B, then they can do it directly. There is no need of this third party. And so there is a lot of transparency in this procedure because I can directly trace the money or there is a money trail over here. So that is what I would like to tell about transparency. Then we have authenticity. Now, I think I would like to explain authenticity also with the help of an example. So, let's look at the food supply chain. So, say there is a person who wants to buy a crate of mangoes. Now, to do this, he would go to the supermarket. Obviously, he would go to the supermarket. But where do the mangoes come to from the supermarket? They would come from the wholesale markets. And to the wholesale markets, it is brought by the distributors or the suppliers. And they get it from the farms where the farmers produce them. So, after this entire chain is followed, that is when this person would be able to access or purchase these mangoes. But at this point, standing in the supermarket, this person might not be sure that the mangoes that he wants to purchase has the exact point of origin that the supermarket claims. So, in this scenario, if we try to introduce blockchain, what would happen here is as soon as the mangoes are produced in the farm and they are packed, and the and this packed mangoes changes authority from the farmer to the distributor or to the seller to the supplier, it is marked as a transaction, and this transaction is uploaded into the blockchain. But the moment there's a change of authority or ownership from the distributor to the wholesale market, this is another transaction. And this transaction is also logged into the blockchain. Then from the wholesale markets to the supermarkets is another transaction. And when you purchase it from the supermarket, this would be marked as another transaction. So all of these transactions would be uploaded onto the blockchain. So at this point, when this customer wants to buy the mangoes, all he would do is have to retrace these transactions to find its point of origin. Now, in this way, the person will not be confused about its point of origin, and hence the feature of authenticity. Now, the characteristic of transparency and immutability is where once a transaction is added to the blockchain, it cannot be altered or changed. It cannot be modified at all. So, the features of transparency and immutability also contribute to authenticity. Next, we have the different types of blockchain. So, why do we need different types of blockchain? The primary aim of blockchain is to carry out transactions or exchange of information through a secure network. But the way blockchain is used would vary from case to case. Based on the usage, blockchain has been classified into three main types: the public blockchain, the private blockchain, and the consortium or hybrid blockchain. Public blockchains are permissionless, meaning anyone with access to the internet can sign in on a blockchain platform to become an authorized node and be a part of this network. The participants in this blockchain can be anonymous and anyone can have access into this blockchain. The transaction speed in the public blockchains are usually slow. Private blockchains are permissioned, meaning only those who have the permission can become a part of this blockchain network. So the participants here are known identities and therefore they all belong to a single organization. The transaction speed in the private blockchain is relatively faster. The consortium blockchains are semi-decentralized or more like a combination of the public and private blockchains. The participants here are also known identities, and the people who can access these are can belong to multiple but selected organizations. And the transaction speed is also fast in consortium blockchains as compared to public blockchains. Now, few examples for public blockchain would be the Bitcoin blockchain, the Ethereum blockchain, etc. And Hyperledger is a very good example for private blockchains. And whereas for consortium or hybrid blockchain, we have an example of Quorum or Corda. So, from the time when blockchain was introduced to the world, it has been evolving rapidly. Now, blockchain 1.0 was focused on currency. At this stage, blockchain was a simple ledger that recorded transactions in a sequence. This represents the state of the network at any given moment. Then we had blockchain 2.0. This stage introduced the concept of smart contracts. We'll discuss about this in the next slide. This represents the state along with the code in the smart contract. Then we have blockchain 3.0. This stage introduced the concept of dApps. dApps as in decentralized applications. They use decentralized storage and communication. The image displayed here shows the difference between regular apps and dApps. Now we can see that these are the regular apps and these are the dApps. You can see that the regular apps have a single data center, so more like a single point of authority or single point of failure. But whereas when we look at dApps, we can see here that each mobile or each application in the mobile is interconnected, or they are more like in a distributed and decentralized network. This represents the state and code along with the front end, giving the ease of usability for the users. Now we have a very interesting concept of blockchains, smart contracts. So a smart contract contains a piece of code that is deployed in the blockchain node. To be more precise, it is an automated computerized protocol used for digitally facilitating, verifying, or enforcing the negotiation and performance of a legal contract by avoiding intermediates and directly validating the contract over a decentralized platform. This is faster, cheaper, and more secure. This was introduced by Nick Szabo in 1996. The usage of smart contracts helps remove middlemen and render transactions traceable, transparent, and irreversible. Take a look at this example. So here we have two parties. So let one party be the buyer and the next party be the seller. So assume that the transaction that they want to that would be taking place here would be the buying and selling of a car. So what happens here is the seller wants to sell his car, but before the buyer purchases it, obviously the buyer would want to take a good look at the condition of the car because he needs assurance about the condition of the car and its quality or how many miles it has covered or something like that. Like because he would also have to maintain the car later on. So for the sake of this, they would come up with a contract with the respective terms and conditions. Now, for the sake of trust, they go to a third party because neither one, because of the lack of trust, they would go to this third party. Now, this third party would make sure that both the parties are following all the terms and conditions present in this contract. Now, only and only after this third party gives a green signal that yes, both the parties have followed their respective terms and conditions, that is when the transaction is assumed to be complete. Well, this process seemed to be a little lengthy and it seems to have involved too many parties. But let's look at this example. We have the same buyer and the same seller, but instead of a contract, we are having a smart contract over here. So, what is the role of a smart contract here? Well, it would have the same terms and conditions that were present in the regular contract, and the only difference is that the smart contract will directly verify the details or will verify that the parties are following the terms and conditions over here instead of the third party. So once the smart contract will give a green signal that both the parties have followed the terms and conditions mentioned in the smart contract, then the transaction is assumed to be complete. So definitely this process looks way faster, and obviously it is way more cost effective than the previous version. So to summarize, I would like to say that blockchain is like a decentralized ledger that can be used in scenarios, especially where there is a lack of trust between the participants. And it is not just another traditional database, because the traditional database allows you to modify the transactions or the data that has been entered into the database. But blockchain does not allow you to do that. So that's all for today. Are we going to have any questions? Please drop them in the chat box so I can answer those. Please drop your questions in the chat box if you have any questions. Okay, thank you everyone. And if you have any further questions, do reach us out at this following email. Thank you very much.